Hello and Namaste. In continuation with the Z transforms, and we are going ahead with the standard Z transform of a standard function. And in this session, we are going to go with cos omega t, sin omega t, e to the power minus at cos of bt, e to the power minus at sin of bt. This type of functions, the Z transform of them. Now, if you'll observe here, this Z transform of cos of omega t is nothing but is equals to Z transform of cos of omega n t. So we have already seen this small t is nothing but can be written as n into capital T, or Z transform of cos of n out omega t. Now again, we have already seen this one of the standard function, the Z transform of standard function, Z transform of cos of n theta is equals to z into z minus cos of theta upon z square minus 2zr cos of theta plus 1 if mod of z is greater than 1. Please reach to the I button and reach to the previous sessions which we have already discussed the standard, the Z transform of these standard functions. Now we are making use of this particular fact over here, and we can directly write down the Z transform of cos of n omega t as z into. So what we are going to do it here exactly. So here theta is getting replaced in this particular formula. Theta is nothing but getting replaced as omega times capital T. That is what we have done it. So z into z minus cos of omega t upon z square minus 2z cos of omega t plus 1. Because r in this case is coming out to be greater than 1. Actually this, in fact, this r should not be here. This should be just 2z cos of theta plus 1. Similarly, we can easily find it out. So this is what we have got it for cos of, this r is not there. We have seen for Z transform of sin of n theta as this formula, that is Z sin theta upon Z square minus 2Z cos of theta plus 1 if mod of Z is greater than 1. Again, we are replacing, or we can check this here in this particular formula, theta is getting replaced as omega capital T, and we'll be getting this particular Z transform of sin omega small t is equals to this. This is according to the standard formula which we have already taken or we have considered already. Again, we can alterly give the find out the Z transform of this function using the traditional way, that is Z transform of cos of omega t. This cos of omega t can be written as e to the power I omega t plus e to the power minus I omega t by 2. This is what half is coming out to be and again Z transform of e to the power minus at is nothing but z upon z minus e to the power minus of a into capital T. The same formula we can apply it over here, and we can just get it because it is nothing but, that means what, the small a, the value of small a is coming out to be I omega, and that is what we can go ahead with this. So 1 by 2 z upon z minus e to the power I omega t plus z upon z minus e to the power minus I omega t. This is what we can check it here easily from this formula. We have got e to the power minus at, therefore we have got e to the power minus a capital T. This is what we have followed it here. So e to the power, if it is a plus at, then it is coming out to be plus a capital T. This is what we have followed it. Then after adjusting the terms and taking the LCM and all this, taking the LCM of this particular thing, and we will be getting this type of function. Again, going ahead with e to the power I omega t plus e to the power minus I omega t by 2 is nothing but cos of omega t. Similarly, the numerator and the denominator will give you this type of function, and that means just by adjusting the terms we are going to get the same as what we have got it here in this case, that is for cos of omega t. So this is also one of the way to just go ahead and find out the Z transform of this particular function. Now, purpose of discussing for me is to discuss about the standard function is you might have this as one of the question. So this, like for example, find out the Z transform of cos of omega t might be a question in the exam. So that is the reason we are just actually in fact we are discussing here the different type of questions rather than you can consider as the formally. So this is nothing but Z transform of sin of omega t. The similar way, the way which we have done it here, we can easily get this particular formula. Therefore, now we have got this Z transform of cos of omega t and sin of omega t in this case in the particular slide. Going ahead with the next, and we'll be going with e to the power minus at cos of bt, the Z transform, e to the power minus at sin of bt, the Z transform of this. Again, Z transform of e to the power at is nothing but Z transform of e to the power at into u of t This is one of the property which we have already discussed it. Now again I'm keeping this property here in front of you so that you can easily follow it up. Now e to the power at u of t is nothing but z transform of ut at z tending to z e to the power minus of at. Please note this is z into e to the power minus of a capital T. In this way it is. So that means what, z is getting replaced as z into e to the power minus of at everywhere in this. But what is the z transform of u of t? Z transform of this unit function or this function is nothing but z upon z minus 1. Therefore, in this function, if we are replacing this z by z into e to the power minus at, we are going to get this again. Again, if you are taking this e to the power minus of at is nothing but 1 upon e to the power a capital T, then adjusting the terms, we will be getting the z transform of this e to the power at as z upon z minus e to the power a capital T. This is what we have used it in the last slide over here. So using this same property, we can go ahead. Z transform of e to the power minus at cos of bt is nothing but z transform of cos of bt and at z tending to z e to the power at. That is nothing but in this z transform of cos of bt, this particular function or the z transform of that from the previous slide, second slide we have seen already, which is nothing but, so z transform of cos of bt is z into z minus cos of bt upon z square minus 2z cos of bt plus 1. Now everywhere in this particular z, if we are replacing this z as z e to the power a capital T, then we are going to reach to the z transform of e to the power minus at cos of bt. So if you observe here, every formula of the z transform is getting connected with each other. That's the reason it's very important to deal with the different standard functions with this z transform. Similarly, we can easily check this up. Z transform of e to the power minus at sine of bt is same. Z transform of sine of bt from the previous step. Please go back and check the z transform of sine of bt is nothing but z into sine of bt upon z square minus 2z cos of bt plus 1. Every z in this particular z transform is getting replaced as z into e to the power at, and will be reaching to the z transform of the function e to the power minus at sine of bt. Similarly, we have got it from this particular. So I've tried to club the two functions or 2 to 4 functions together so that I can take the help of the previous and go ahead with the z transform of the next one. Very, very important. So in short, if you could understand that as this is nothing but a questions we are discussing, how to go ahead, how to find out the z transform of different functions. These are not only the standard functions, the z transform of standard function, but whereas you can consider them as the different questions as well. This is what about this particular session. Please stay connected, stay tuned for the upcoming. Thank you.